Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. It's late at night, your laptop screen is the only light in the room, coffee's gone cold, and your CI pipeline is red again. You're not alone though. An AI code agent is running beside you. It scans the error message, skims the stack trace, jumps into the repo, confident, fast, tireless. It proposes a fix. You run the tests, green. You smile, merge the PR, go to sleep. And 2 days later, production breaks. Not because the agent was stupid, not because it couldn't write code, but because it fixed the bug alone. No memory, no history, no sense that someone somewhere has made this exact mistake before. Because here's the uncomfortable truth: the best software engineers don't debug from scratch. They remember, they remember a weird GitHub issue from years ago, a half buried PR comment, a fix that almost worked and why it failed. Human debugging isn't just logic, it's experience. And today's AI agents, they wake up every morning with amnesia. This is the problem at the heart of a paper called Enhancing Code Agents Through Learning from Governed Human Experiences by Chia Wang and Ximing Cheng, along with a large research team. And this paper asks a deceptively simple question: what if code agents could learn the way humans actually do? Let's zoom out. Autonomous software engineering agents are impressive. They navigate repositories, run tests, edit files, submit patches. Benchmarks like SWE-bench prove they can solve real issues. But there's a limitation hiding in plain sight. Most agents live in a closed world. They only see the current repository, the current issue, the current code. Meanwhile, the real world of software engineering is open. When humans hit a bug, they don't just stare at the code, they search. They Google the error. They scan GitHub issues. They read how other people solved similar problems. That collective debugging knowledge is enormous. GitHub is not just code, it's millions of failure stories, arguments, false starts, root causes discovered the hard way. So, why don't agents use it? Because GitHub experience is a mess. Issue threads are noisy. PRs mix social chatter with technical insight. Every repo uses different terminology, structure, and style. To a machine, it's chaos. So most systems either ignore this experience or naively dump it into embeddings and hope for the best. MemGovern takes a different path. It says before agents can learn from human experience, that experience needs governance. The core idea of MemGovern is simple to say and hard to do: turn raw human debugging history into something an agent can reason over. The solution: experience cards. Think of them like memory flashcards for bugs, but not scraped notes, not raw diffs. Carefully governed, structured representations of how humans actually fixed real bugs. And building them happens in 3 stages. Stage 1: experience selection. Not all GitHub data is worth learning from. MemGovern starts by choosing healthy repositories, active projects, real users, ongoing maintenance. Then it filters for closed loop fixes, meaning you can trace the issue to the pull request to the final patch. No speculation, no half finished discussions. Already a massive amount of noise disappears. Stage 2: experience standardization. This is the heart of the system. Each debugging story is rewritten into a standard format. And here's the key design choice: every experience card has 2 layers. The first is the index layer. This is what the agent sees when searching. It contains a clean problem summary, diagnostic signals like error types or failure modes. Crucially, no repo specific names, no variable soup, no irrelevant details, just symptoms. The second layer is the resolution layer. This is the wisdom. It captures the root cause, the fix strategy, a semantic summary of what changed, how the fix was verified, not raw code, but reasoning why this bug happened and why this fix works. This separation matters. It lets agents match on symptoms and reuse logic across repositories. Stage 3: quality control. Because automated pipelines aren't perfect. MemGovern runs each experience card through a checklist. Is the root cause clear? Is the fix coherent? Is anything hallucinated? If something's off, the card gets refined. Only high confidence experience enters memory. The result? About 135,000 governed experience cards, not data, actual debugging memory. But memory alone doesn't solve bugs. Agents need to use it correctly. And this is where MemGovern avoids a classic trap. Standard RAG systems do one thing: retrieve and dump everything into context. That's not how humans debug. MemGovern introduces agentic experience search, two primitives. First, search fast, broad, cheap. The agent scans index layers for similar symptoms. Then browse, slow, focused, deliberate. The agent opens a small number of experience cards and studies the resolution logic. This mirrors human behavior. Skim broadly, then dive deep. Why does this matter? Because raw retrieval is dangerous. The paper shows cases where naive RAG pulls in experiences that sound similar but are completely irrelevant. Front-end formatting issues, local bugs, CSS fixes, all because of shared keywords. Agentic search lets the agent reject bad matches. It doesn't just retrieve, it reasons. There's a powerful case study in the paper, a Django bug involving query expressions. Without experience, the agent applies a quick fix, a defensive bypass. It stops the crash but violates the API contract, a silent failure waiting to happen. With MemGovern, the agent retrieves a human experience card. It learns what assumption was violated, why the naive fix is wrong, how to preserve semantic correctness, and it implements the right fix. Same bug, different outcome. The results back this up. Across multiple LLM backbones, MemGovern consistently improves performance. On SWE-bench verified, an average improvement of 4.65%. For weaker models, even bigger gains. Yes, it costs extra tokens. That's the trade-off. More memory access for fewer wrong fixes, and the authors argue convincingly that it's worth it. There are important lessons here. One pitfall: raw experience can make agents worse. Unprocessed PRs overwhelm context and distract reasoning. Another pitfall: bigger memory isn't automatically better. Without selective browsing, retrieval turns into noise. MemGovern works because it governs both what is remembered and how it's accessed. So, what's the real takeaway? This paper isn't just about bug fixing, it's about how we think AI agents should learn, not by guessing harder, not by generating more tokens, but by standing on the shoulders of human experience. Debugging is not just computation, it's history. And MemGovern is one of the first systems to treat that history with the respect it deserves. So, the next time an AI agent fixes your bug, ask yourself, is it just reacting or is it remembering? Because the future of software engineering agents won't be built on intelligence alone, it will be built on experience. And now, for the first time, we are teaching agents how to remember. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.